Okay, in this video, I'm going to show you how to graph y equals 2 sine 1/2 x. So the 1/2 x are inside the sine value. So for this is in the format y equals a sine bx. Now in the last video, I talked about a, the amplitude, and that just tells us how high the maximum and minimum are going to go. So in this case with the 2, we would bring our graph instead of here, this green graph here is just y equals sine x. So to bring the 2 in, we're just going to bounce all the way up here to 2, and then down when we go down below, we go through 0, and then when we go down below, we would end up down here at -2. But this 1/2 changes our dynamic. This right here, a normal y equals sine x, or something that's not having anything done to it, goes from 0 to 2 pi. That is considered one cycle or one period. So here our B represents the types of periods that we have, or how big or how long our cycle is. So to determine our period, we need to use the equation 2 pi divided by B. And this will tell me the length of my cycle or my period here. So I'm going to go ahead and plug in for B. This is the equation I'm graphing up here. This is just the generic form. So I'm going to go ahead and plug in 2 pi divided by my B value, which is 1/2. Okay, so dividing 2 pi by 1/2, we would just say 2 pi divided by 1/2, and therefore 2 pi times 2, or 4 pi. As you notice, my graph here is going from 0 to 4 pi. So now I'm going to stretch my original sine. I'm going to stretch this, like if I could drag this point, I would drag it all the way out to the 4 pi, because now my period has been stretched out. It takes half the, let's see, how do I explain it? I think that's backwards. So it takes a whole time to go here. It's going to take, we'll only be able to get half done from 0 to 2 pi. So that's why we only get half of our cycle done, and the full cycle will take us all the way to 4 pi, if that makes sense. Okay, so let's go ahead and graph this. Let me put it in a different color. So we know we are still going to be, when we plug in sine of 0, we were still going to start here at 0. But when I plug in pi over 2, it's actually going to be pi over 4. And then we're going to take that number and multiply it by 2. But I don't want to go to pi over 4. It's much simpler if I just go to pi, right? So if I plug in pi, that's going to give me the pi over 2. So that is at pi is going to bring me at 2. And then I'm going to switch over to 2 pi. When I plug in 2 pi, I'm just at pi, which is actually 0. 0 times 2. And I'm going to end up here because we're dividing those by 2. And then my next is I'm going to go over all the way to 3 pi. So my 3 pi here times 2 is going to bring me down to -2. And then at 4 pi, so notice I'm skipping these here because you're going to end up with not whole numbers. I just want to graph the whole numbers. I don't want to be halfway in between the graphs. That's why I skipped those, because it takes twice as long to get this graph, or twice as far out to get this graph. And then our graph here is going to look like this. So again, the 2 on the outside tells me my maximum and my minimum, and this 1/2 x here tells me that instead of going from 0 to 2 pi, this graph is going to go from 0 to 4 pi, so it stretches it out. So hopefully that makes sense. We've got one more translation here. We're going to add one more thing in here. So I will see you in the next video. If you need to pause and relook at this, please do.